This video is about solving for a missing value using properties of similar figures, identifying similar triangles using angle-angle similarity, side-angle-side similarity, and side-side-side similarity. So the first method is angle-angle similarity. In angle-angle similarity, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we look at these two pictures here, by looking at the markings, we can see that angle A is going to be congruent to angle D, and we can see that angle B is congruent to angle E. So because we have two sets of angles congruent, we now know the triangles are similar. So triangle ABC is similar to DEF by angle-angle similarity. In angle-angle similarity, you don't need to show that all three sets of sides of angles are congruent, because if two sets are, the third set by default would have to be. So you only need to show that there's two sets that exist in order to use angle-angle similarity. Our next method is side-side-side similarity. In side-side-side similarity, if three sides of one triangle are proportional to the three sides of another triangle, then the triangles are similar. So, in this case, we see that the triangles have numbers. We don't really know which sides correspond with each other, but we know the shortest side has to go with the shortest, middle side has to go with middle, longest with longest. So the shortest side right now is 3 and 6 from the two triangles. So 3 over 6 reduces to 1/2. Our middle side length is 4 and 8. So we have 4 over 8, which reduces to 1/2. And we have the longest side, 6 over 12, which also reduces to 1/2. So because they all reduce to the same fraction, we can say that triangle ABC is similar to triangle DEF by side-side-side similarity. The last method then is side-angle-side similarity. So in side-angle-side similarity, if two sides of a triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. So as we see here, angle A and angle D are between the sides with the length. So we also see by marking angle A is congruent to angle D. Then we're going to look at our proportions. So the shorter sides are going to go together, 3 over 9, which reduces to 1/3. And the longer sides are going to go together, 4 over 12, which also equals 1/3. So we would have triangle ABC is similar to triangle DEF by side-angle-side similarity. So let's look below and see why these triangles are similar and then write similarity statements. So in number 1, we see that we have a larger triangle and then a smaller triangle inside. So the larger triangle is PRT and the smaller triangle inside is QRS. So as we see in these triangles, we have no side lengths, so we're going to have to see if angle-angle similarity will work. So as we look at this triangle, we see P and Q are both right angles, so they would have to be congruent to each other because right angles have the same measure. We also see that the triangles are overlapping at angle R, so we can use reflexive property so that angle R is congruent to angle R. Now that we have two sets of congruent angles, we can say that triangle PRT is similar to triangle QRS by angle-angle similarity. In number 2, we have a bow tie problem of two triangles, and we have these triangle markings on the side, which means that those lines are parallel. So because the lines are parallel, we could use alternate interior angles to have one set of angles congruent. So angle H is congruent to angle K. In a bow tie problem, remember from proofs, we can also use our vertical angles. So angle HIL is congruent to angle KIJ. And because we have two sets of angles congruent, those triangles are now similar. So triangle HIL is similar to triangle KIJ by angle-angle similarity. In number 3, we don't have any markings to show that the lines are parallel, but we do have some side measures. So if we look at our vertical angles, we have the included angle now congruent, so we know that angle MNQ is congruent to angle PNO. But that only gives us one set of angles that's congruent, so now we need to look at our side measures. So if we set the two smaller sides, 12/10, that's going to reduce to 6/5. And if we look at the longer sides, we have 18/15, which is also 6/5. So we know that the triangles are now similar. So triangle MNQ is similar to PNO by side angle side similarity. In number 4, we see that it has no common angles, but we see that there have 3 different sets of side measures. So the smallest sides are going to match up together, 4/8, which reduces to 1/2. The middle lengths, 5 and 10, which also reduce to 1/2. And then the largest sides, which would be 6/12, also reduces to 1/2. So we have triangle JKL is similar. Now we have to be careful. So as I name this and I look at JKL, I went the medium side length to the longest. So if I go the medium side length to the longest, this second triangle would be VUT, and then they are similar by side similarity. In number 5, we have triangles with parallel sides. So we have a smaller triangle inside with a bigger triangle. We can use corresponding angles. So we would have that angle F is congruent to angle L. Also, again, because of the overlapping triangles with that larger triangle and the smaller triangle inside, they have a common angle at angle A. So we can use reflexive property to say that angle A is congruent to itself. So angle A is congruent to angle A. So then we can say that the triangle FAE is similar to triangle LAK by angle-angle similarity. Number 6 is a little bit tricky because we have a triangle and then another triangle inside. We see right now that angle SNW is congruent to angle O. So if I look at the two triangles that contain those, I can see this triangle, and then I'm actually going to use the bigger triangle here. And I want to use that because if I looked at just the smaller two triangles, there's nothing in common to get a second angle measure. But now that I use the bigger triangle and then the triangle that's in yellow, S is a shared angle, so angle S is congruent to angle S. So we would have triangle SNW is similar to triangle SON by angle-angle similarity. So now we can apply this to helping us solve. So in number 7, we need to explain why triangle RIC is similar to triangle BIK. Then we want to solve for x and find the ratio of the sides. So in number 7, we see that we have parallel lines, which means we can use our corresponding angles to be congruent. We also have the larger triangle BIK, and then the smaller triangle RIC inside. And we notice that they have a shared angle which is angle I. So since we know that angle B is congruent to angle R, and angle I is congruent to angle I, we know that the triangle RIC is similar to triangle BIK by angle-angle similarity. So now we can solve for x. So when you are solving for x, you can use the triangles together, or if it's a little bit easier for you to visualize, you can break the triangles apart and relabel them. So RIC is x minus 1, and RC is x plus 9. Then in the bigger triangle, we have the sides BIK. So BK is 39. IB, which is this whole side length, we would add those together. So x minus 1 plus 8 would get us x plus 7. So now that we have those sides, we can set up a proportion to solve. So we would have x minus 1, which is the shorter side, over the larger side x plus 7 equals x plus 9 over 39. And then as we are solving this, we would cross multiply. So we get 39 times x minus 1 equals x plus 9 times x plus 7. So we get 39x minus 39 equals x squared plus 7x plus 9x plus 63. We see that there's an x squared, so we're going to have to move everything over to the x squared side. So we get 0 equals x squared. And then I have 7x plus 9x minus 39x, which gets us 23x, negative 23x. And then I can add 39 to the other side to get 102. So now I need to factor. So when I'm looking, I need numbers that multiply to positive 102 and add to negative 23. So we have x minus 17 and x minus 6. So x is going to be 17 and x is 6. So we're not done yet because we are looking for the ratio of sides. So because both x's will work with positive values, we need to find the ratio of sides twice. Remember, the ratio of sides is equal to the old triangle side over the new triangle side. So the old triangle is the first one listed, the new triangle is the second one listed. So if x is 17, the ratio of the sides, 17 minus 1 is 16, 17 plus 7 is 24. So I have 16 over 24, which would be 2/3. Then if x is 6, the ratio of the sides would change because we're going to have different side lengths. So if I put 6 in, 6 minus 1 is 5, and 6 plus 7 is 13, so we have 5 over 13. And number 8, explain why triangle ABC is similar to triangle EDC, and then solve for x and y and find the similarity ratio. So one thing we're going to do is we're going to change this 2x plus 3 to be 2x plus 13. So now if I'm looking at the triangles, figure out why they're similar. Because of the parallel lines, we would know that angle A is congruent to angle E because alternate interior angles are congruent. We can also use our vertical angles. So angle ACB is congruent to angle ECD. So we now know that triangle ABC is similar to triangle DEF by angle-angle similarity. So if I'm going to solve for x, I see two sides that have an x, and they are the parallel sides of the triangle, so they would be the corresponding sides. So when I go to solve for x, I would have x plus 3 over 2x plus 13 equals, just like when we had congruent triangles in a bow tie problem, remember that the sides that corresponded were on the same diagonal, so we would have 2 over 6. So as we cross multiply, we get 6 times x plus 3 equals 2 times 2x plus 3. 6x plus 18 is equal to 4x. This is going to be is going to be 13. So 4x plus 26. So as we solve then, we get 2x is equal to 8. So x is going to equal 4. Then to find y, we're going to stick with the 2 over 6. And we're going to set it equal to the last set of sides. So we would have 5 over 6y minus 9. So as we cross multiply, 2 times 6y minus 9 equals 5 times 6. 12y minus 18 equals 30. We can add 18 to both sides. 2y equals 48. We can divide by 12. So y is also 4. Then we want to find the similarity ratio. So our similarity ratio, remember, is the old side over the new. So the similarity ratio, which is the ratio of the sides, aside from the original triangle is 2, aside from the new triangle is 6. So our similarity ratio here would be 1/3. In number 9, triangle VREN is a parallelogram. Name the similar triangles and then solve for x. So if we have a parallelogram, we know that the opposite sides are parallel. So that means that RE is parallel to VN. So because those sides are parallel, we can then use our corresponding angles. So angle N is congruent to angle E, and angle K would be congruent in both triangles. So we now know that triangle VKN, the bigger triangle, is similar to the smaller triangle AKE. So now we want to solve for x. So if we're looking at our bigger triangle and our smaller triangle, the smaller triangle has two sides. It has 9 and x. So if we're going to use 9, the side that corresponds is this longer side. So we need the full length, which is 24. So 9 over 24 equals, on the other side we have x, and the side that corresponds with it is this full side, which is x plus 20. So as we cross multiply here, we get 24x equals 9 times x plus 20. 24x equals 9x plus 180. 15x equals 180. So when we divide, x is 12. In number 10, we have triangle BCD is similar to triangle ACE. We want to solve for x and y. So you can either just look at the triangle as is, or if it's hard for you to visualize, you can always redraw the triangles broken apart. So we have BCD, which is 24, 10, and x minus 5. And we have triangle ACE, where AE is 52. CE, we need to add these two together, so we would have y plus 10. And then we have this other side that we have to add together. 15 plus 24 is 39. So as we are solving for x, we see we have one x variable, the x minus 5, which corresponds with the side of 52. And then I'm going to pick the sides that have the two numbers. So we have 24 over 39. We can't do 24 over 15 because 15 doesn't represent a whole side of a triangle. So make sure you're very careful there. So when we cross multiply, we have 39 times x minus 5 is equal to 1,248. So we get 39x minus 195 is equal to 1,248. We can add 130 or 195 to both sides, so 39x equals 1,443. When we divide, x is 37. Then if we're going to solve for y, we're again going to use the 24 over 39. And then we're going to use the last remaining sides. So we would have 10 over y plus 10. So as we cross multiply, 24 times y plus 10 equals 39 times 10. So 24y plus 240 equals 390. 24y equals 150. So when we divide, x is 6.25. In number 11, we have triangle JLN is similar to KLM. So as we're looking for the full sides, JL, when we add this together, is going to become x plus 17. And then we have x plus 26 for NL. If you want, you can redraw the two triangles. So if we redraw them, NJL, we have x plus 17, x plus 26, and y plus 9. And the smaller triangle of MKL, we have 15, x plus 10, and 10. So as we look at the first triangle, the smaller one in blue, the larger one in yellow, we see that there's two sides with an x in it. So we are going to use those corresponding sides to solve for x then. So we would have x over 17 over 15 equals x plus 26 over x plus 10. So then we can cross multiply. We get x plus 17 times x plus 10 equals 15 times x plus 26. So we get x squared plus 10x plus 17x plus 170 equals 15x plus 390. So this is going to be a factoring problem, so remove everything to the x squared side. So we get x squared plus 12x, because we had 10x plus 17x minus 15x. And then we're going to subtract 390 to get both sides to get 220 equals 0. So what multiplies to negative 220 and adds to 12? We would have x plus 22 and x minus 10. So x would equal negative 22 and x would equal positive 10. We're going to get rid of the negative 22, so just x is 10. So then we can substitute 10 in for x on one of the sides. So I'm going to do it on the bottom side. So x, which is 10 plus 26 is 36, and 10 plus 10 is 20. So I can use 36 over 20 equals our remaining sides, so y plus 9 over 10. So as we cross multiply here, we get 20 times y plus 9 equals 36 times 10. 20y plus 180 is equal to 360. We can subtract 360 on both sides. So 20y equals 180. We divide, y is 9.